Hey everyone. All right, we're going to do a quick lesson on radicals and perfect squares. So when we go to our solving with radicals, we can make sure we're good to go. So first thing I want to talk about are perfect squares. So there are several perfect squares in our real number system that we need to talk about. So a perfect square is when you have a number, then you square it or take the square root of it, you get a real number, a rational number out of it. So what I mean is we have 1 squared, which equals 1. So if we were to take the square root of 1, we would get 1 out of it. Same thing with 2. If we square 2, okay, we would get 4, which means if we take the square root of 4, we would get 2. Along the same lines, 3 squared would give you 9. So if I took the square root of 9, my square root would be 3. It just means that we can take the square root of that number and get a nice, pretty integer that we're looking at. So then, continuing this pattern, 4 squared equals 16. So if we take the square root of 16, we get 4. Okay. So if you notice, the numbers on the equal sign of the root also match the base of the number that we originally squared. Okay, so, and that should match all the time. So there's a few in our number system that I should expect you to be able to memorize, and these are the ones that we're writing down in our notes right now. So 5 squared is 25. So when I take the square root of 25, I should get 5 back, and I do. So continuing, I have 6 squared, which is 36. So square root of 36 should be a 6. Okay. And we're going to talk throughout this note section, not this note section, but our solving with square roots about the different answers you can get for your radicals. So continuing, we have 7 squared equals 49. So if I take the square root of that, of 49, then I should get 7. So then 8 squared, okay, I get 64. So then if I take the square root of 64, I should get 8. Okay. Continuing, 9 squared, 81. So if I take the square root of 81, then I should get 9. So it works forwards and backwards. So if you square a number and then, take the square root, you should get one of the originals that you started with, something along those lines. So we stopped at 9 squared, so 10 squared, you have 100. So if I take the square root of 100, I should get 10. 11 squared is 121. So if I take the square root of 121, I get 11. 12 squared, I get 144. So then if I take the square root of that number, then I should get 12. Okay, so if I square it and then get the square root, then it should match. So continuing, there's a few more that are really helpful if you know. So 13 squared is 169. So then if you take the square root of that, you should end up with 13. And then 14 squared equals 160 or 196. I'm sorry, it's just the numbers flipped. So then if I take the square root of that, I should end up with 14. Okay, so you should see these little patterns emerging. So there's just a couple more that I think are really helpful. So we have 15 squared, that gives you 225. So if I take the square root of 225, I get 15. Okay, so then 16 squared, if I take 16 squared, then I should get 256. So then if I take the square root, then I should get 16. So these are a few of the ones that are pretty notable. Like these are ones that you should be able to identify. So there's 2 more that I want to show you. So 17 squared is 289. And then the square root of that is 17. And the last one, we're not going to do 18 or 19, but we're going to talk about 20 squared. 20 squared is 400. So if I take the square root of 400, you get 20. Okay, so these are the ones that I will expect you to memorize and know, and a lot of them you already do, but it's probably the larger ones, the ones that are after 12, like the 13, 14 through 20, that maybe you don't. So with this, if we use this information appropriately, we can simplify radicals whether they're perfect squares or not. So I want to take a look at the practice below. Okay, so the practice below here. So we're going to simplify these radicals, whether they are perfect squares or not. So I want to take a look at some that are perfect squares first. So like number 3 is a perfect square. Okay, the square root of square root of 36. That's one of the ones we listed above. Okay, it's right here up top. Okay, 36. Square root of 36 is 6. And the reason for that, because something I want to show you is, 36 is 6 times 6. Okay, so when you have an identical factor multiplying together, what you really have is the square root of 6 squared, and this radical will actually cancel with the exponent inside. So what's left is then 6, the root. Okay, so same goes for numbers 2 and 4. So 2 and 4 here, so for number 2, it's the square root of 16. So we have here the square root of 16 is 4, but the reason for that is we have 4 times 4 underneath, which does give us the square root of 4 squared, which cancels the radical with the exponent, and you're left with the 4. Okay, so when you have perfect squares like this is why it works. And so I know we have calculators, so we can just do it in the calculator, but it's not always going to work out all nice and pretty in the calculator. So it's nice to know why it works, so you can kind of use that to help solve when radicals aren't perfect squares. So this leads us to number 1. Okay, this leads us to number 1. So the square root of 75. Okay, so my video stopped working about halfway through this, so I'm going to do this again. So 75 is not a perfect square. It's actually between 64 and 81. So you can see that we don't have a perfect square for that number. So when you have this issue where you have a square root of something that is not a perfect square, the first thing you're going to do is list out the factors for that number. Okay, so I'm going to say 1 and 75, 3 and 25, and 5 and 15. Okay, so when we list out our factors, and you're not going to have to do this all the time, just so you can kind of understand where this is coming from, you're looking for the largest perfect square that is a factor. Okay, so the largest perfect square. So when I look at my factors, 5 and 15, those are not perfect squares. So if you took the square root of 5 and you took the square root of 15, you would not get a nice pretty number. Okay, so those are not an option. So 3 and 25, 25 is a perfect square from our list. 1 and 75, 1 is also a perfect square from our list. However, we're talking about the greatest perfect square. Okay, so when we're talking about the greatest perfect square, we would need to use 3 and 25. Okay, so what we're going to do is take our radical and we're going to separate 75 into its factors of 25 times 3. It still says 75, but it's just now written as 25 times 3. And something we can do with radicals that has the property that if we have a product, we can separate that multiplication into 2 radicals. Okay, so now we have the square root of 25 times the square root of 3. So now we know the square root of 25 is 5 from our list. 3 is not a perfect square. If you took the square root of 3 and did it in your calculator, you would get an irrational number. So we can't simplify that anymore, so we're just going to bring it down and put it next to the 5. So we simplified the square root of 75 and made it into 5 root 3. And I'm going to show you that we did a great job of that because this is how you're going to check your work. Okay, so if you have your calculator, square root of 75 equals this number. So now if I take 5 square root of 3, I should also have an identical number, which I do here. So that means I did it correctly. So if you're wondering if you did your work right, this is how you need to check yourself. Okay. So when you also do your work, you should double check to make sure you took the greatest perfect square. In this case, we did. Okay. So I want to jump down to number 5, and we're going to take a look at this one. So 5 is the square root of 80. So 80 is not a perfect square. It is really close to 81, okay? But it is not a perfect square. So we need to look at its factors. So factors of 80, 80 is even, and it always has a factor of 80 of itself and 1. So it's even, so we can take it divided by 2, which we get 40. Okay, if we take 80 divided by 4, that's now 4 and 20. 80 divided by 5 gives us 16. And then you just keep looking for factors. So then we have 8 and 10, and I believe that's it. I don't think there's any other ones. If there are and we missed them, that's okay. Hopefully, we didn't miss any. So again, we're looking for the greatest perfect square. Okay, so something we can take the square root of and it will give us a nice pretty number. So here 1 is always a perfect square. 2 and 40, neither of those are perfect squares. Okay, we do have 4 and 20. Okay, so we need to take a look at that one. We have 5 and 16. 16 is also a perfect square. And 8 and 10 are not. Okay, so if we tested those in the calculator, we would get really big decimal numbers. So now we have 3 options to choose from. Okay, but we want the greatest perfect square factor, which is 5 and 16. So what we're going to do is we're going to set it equal to the square root of 16 times 5. Okay, still gives us 80, but it's just written differently. We can separate into individual radicals. And then we know the square root of 16 from our table up here. The square root of 16 is 4. So I can write 4 instead of square root of 16. And then square root of 5 we know is irrational. So I'm just going to bring it down. So we're going to test this out really quick. So square root of 80 gives us this nice decimal. Then 4 square root of 5 gives us the same decimal. Okay, so that's a way you can check your work. All right, so I want to talk about one more before we end this little video. I want to take a look at number 6. So number 6, we have square root of 30. 30 is not a perfect square. So I want to take a look at the factors of 30. So I have 1 and 30. I have 2 and 15. I have 5 and 6. And I believe that's it. I don't think there's any other ones. So if we're looking for perfect square factors, we obviously have 1, okay? 2 and 15 are not, okay? And 5 and 6 are also not, okay? So that leaves us with 30 and 1, okay? So if you're finding yourself in a situation where you're left with the number times 1, and that's the greatest perfect square you have, that means that this cannot be simplified any further. So you could write already simplified, or cannot be simplified further. Okay, So there are times where this does happen, where it's not no solution, because you do have a solution. Your answer is the square root of 30. Okay, that's the answer. It's simplified already. There's nothing you can do. Okay, so that does happen. So I'm going to add a few practice problems to the end of the video. Just let me know if you have any questions. Have a good day.